So welcome everyone. Welcome to Strait Science. Strait Science is an evening seminar series put on by University of Alaska Fairbanks Alaska Sea Grant here in Nome, and also University of Alaska Fairbanks Northwest Campus, also of Nome. And tonight you're in the office, and both Northwest Campus and Alaska Sea Grant, we are public servants of the Bering Strait region. We serve all peoples of the Bering Strait region, which is the homeland and waters of the Inupiaq, St. Lawrence Island Yupik, and Central Yupik peoples. Now, tonight we've got a good Strait Science because they're working literally right in the strait. And we have tonight Michael Cameron's going to lead us off. He is the lead biologist for the NOAA Polar Ecosystem Program, currently located in the Alaska Fisheries Science Center building that is in Seattle. And Erin will then, he'll do the first portion, and Erin will bring it home at the end and give us the big summary. And Erin is the senior ice seal biologist, also of NOAA's Polar Ecosystems Program. And just as a cautionary tale, Seattle has, I guess, been in the 70s recently. And right now they're anticipating, you can kind of see that's getting dark there for Michael Cameron and for Erin and anyone else in Seattle, but they have a tornado and hail and severe thunderstorm warning. And so we may be a little hampered. We had some low bandwidth at Seattle's end, which is sort of that's different for us. And so we'll be patient while they struggle. If they struggle at all, that'll be very gnome-like, and we will understand. So they also ask, maybe because of this situation, it might be better if you have a question, feel free to ask your question during the presentation. Don't save it till the end, because if they have to go offline, if they lose power in Seattle or something, then you'll at least get your money's worth tonight. I think we just saw lightning behind you. Yep. Oh, lightning in front of you. All right, the NOAA Ice Seal aerial survey should be no surprise to the region. We've had aerial surveys in the past, and Michael Cameron and Erin have been a part of that, and they have done a great job of informing us before, during, and after. And tonight we're going to hear the 2025 plans for this year's upcoming and soon to be aerial survey of the Bering, Chukchi, and Beaufort Seas, which will include the Bering Strait region. With that, Michael Cameron, take it away. Thank you so much for coming.
Absolutely. Thanks so much, Gay. And thanks to everybody for joining. I really like this Strait Science series. It's a great way to have sort of a low pressure discussion with everyone who's interested in the topics that we're bringing up. And this is a topic that I'm really excited to talk about. As Gay mentioned, we'll be conducting aerial surveys for ice-associated seals starting in just a few days, actually. This is a project we've been planning for years and years, and we're really excited that it's finally going to be happening. My name is Michael Cameron. I'm the leader of the Polar Ecosystems Program. I'll start us off with a little bit of background. The majority of the project is going to be discussed by Erin Moreland. A quick background, as I mentioned, I'm the leader. My name is Michael Cameron. I'm the leader of the Polar Ecosystems Program. I have a lot of experience researching seals in polar regions and a lot of work specifically dealing with co-management. And I was born in Portland, Oregon. My wife in this photo here is Colleen, and my son Colin, and my daughter Kate. I wanted to mention that my son Colin was given the Inupiaq name Anaway by John Goodwin of Kotzebue, and my daughter Kate was given the Inupiaq name Siletkutok by Billy Adams in Uktiavik. And I bring that up just to say that I'm really proud of my connections that I've had with Alaska Native communities throughout Alaska. And it's something that really has helped to continue to inform my way of interpreting all the work that we do and understand the value of it to the communities. Next slide.
And my name's Erin Moreland, and I've been working with NOAA for about 25 years. I started in Hawaii with the Pacific Islands Fisheries Science Center and their remote Hawaiian monk seal field camps. So started in warmer places. I was lucky to come to the Alaska Fisheries Science Center back in 2006 and have enjoyed the expansive types of work that our program does and the joy of getting to explore different areas of Alaska and get to know folks throughout the area. I grew up in Los Angeles, and I went to as far away as I could get from Los Angeles and still be in state to go to college. I went to Humboldt State University and studied zoology. And then I studied environmental science for my master's degree at Western Washington University. And here in Seattle, I have built a little family. That's my husband, Brent, our puppy, who's now a few years older than that, and our girls, Abigail and Allison.
Thanks, Erin. So as Gay mentioned, I'm with the Polar Ecosystems Program, part of the Alaska Fisheries Science Center, NOAA Fisheries. That's the AFSC. Our group at the Polar Ecosystems Program, we monitor and study seals in Alaska in order to support management and co-management. And we do that through a series of aerial surveys of the types you're going to be learning about. We also conduct a lot of research out of vessels, ships, or village-based projects, often involving satellite tagging and tracking of seals. We've got dozens of vessel and village-based tracking projects and aerial surveys that we've been conducting since the early 1990s. We also have a very active group that is developing new methods, often statistical methods, but also hard methods for being able to survey and estimate population numbers and trends, which is exactly what we're going to be talking about today. Next slide. So our program studies the 5 seals in Alaska, the harbor seal, as well as the spotted seal, ribbon seal, bearded, and ring seal. Those last 4, the ringed, bearded, ribbon, and spotted seals, collectively are called ice seals or ice-associated seals, and that's because they utilize sea ice for important parts of their life history, like timings of giving birth or nursing their young or molting or resting. The ringed and the bearded seal have recently been listed as threatened under the Endangered Species Act, not because they're currently experiencing low numbers or problems. In fact, currently, we believe their populations are probably relatively healthy. It's mostly because of a concern out of a loss of habitat that's predicted to happen by the end of the century. Mostly that is a reduction in their sea ice and their snow habitat. Next slide. So anthropogenic or human-caused climate change has warmed the atmosphere, the ocean, and the land with lots of global impacts. And since the 1970s, the Arctic has been warming up 4 times faster than the rest of the planet. And this loss of sea ice has diminished the amount of current sea ice, and that's been going back the amount of sea ice that's been lost has been unprecedented, going back over centuries. And this loss that I mentioned is continuing to happen, and it's actually speeding up. So the figure you're seeing here is a map of showing the decadal or mean or average sea ice concentration for the Arctic over the 2010-2019 period, where percent ice concentrations are shown in various colors, with red being high ice concentration and blue being low average ice concentration. 1 degree of temperature change is the difference between liquid water and solid ice. So we would expect the largest changes to be occurring at the southern margins. Next slide. Just like in the Alaska's Bering Sea and the Sea of Okhotsk in Russia, where you can see that by the end of the century in 2090 and 2099, it's predicted to be nearly ice-free in May in the Bering Sea and the Sea of Okhotsk. The warming trend for the first half of the century has already been set due to greenhouse gases that's already happened. And we expect the impacts to ice seals to not be uniform and will therefore depend on different species distributions and the timing of all of their different life history as impacts. It's these changes in sea ice habitat and snow that are motivating our need to understand what's happening to the populations. What are their trends? Next slide. So these warmer temperatures and the reducing concentrations of sea ice also mean that there's less and less multi-year ice. That's multi-year ice is ice that's persisted for more than 1 year. Multi-year ice tends to be thicker and harder, more likely to create ridging. This chart here shows the average thickness of sea ice in the Arctic and shows that it's declined between 1/2 and 2/3 since the late 1970s. Next slide. This older ice is thicker and more stable, and so, as I mentioned, more likely to produce the sort of ridging that creates windbreaks for ring seals and to facilitate the accumulation of snow for their subnivean layers. Next slide. The IPCC forecasts a nearly ice-free Arctic in September by the end of the century, meaning, of course, very little multi-year ice. Oh, sorry, you can go back to the next slide. Thanks. So in this context of a changing climate and changing habitat for ice-associated seals, that sets the context for why we want to be able to study and monitor and research these seals. We have indications that the seals themselves are responding to these changes, particularly in the Bering Sea, the southern boundary where the changes are most dramatic. We've identified declines in their body condition or the fatness of some species and most of the pups of these species. And for this reason, it's more important than ever to be monitoring these animals. We know that most of the important things to monitor can only be measured in the springtime, right around now, when local residents hunt marine mammals for food. And I think we've shown over our decades that we have the ability to conduct our work safely while also not impacting the success of hunters trying to provide for their family. NOAA, the overarching organization that I work for, has a mandate under the Marine Mammal Protection Act and the Endangered Species Act in order to manage and conserve marine mammals. And the Marine Mammal Protection Act in particular establishes a way for NOAA to actively co-manage these species directly with indigenous groups and tribal nations. Next slide. NOAA has a co-management agreement with the Alaska Native Ice Seal Committee, where there are representatives from the 5 different regions that take ice-associated seals for subsistence purposes. Together, this forms a sort of committee that helps to identify research goals and help direct monitoring plans. There's also a working group in addition to the co-management part of NOAA and the Ice Seal Committee. This working group includes state partners like the Alaska Department of Fish and Game, a lot of other educational institutions like University of Alaska Fairbanks and others, and other institutions. Altogether, we develop an Alaska Ice Seal research plan each year. What I'm showing you here is the cover of the most recent Alaska Ice Seal research plan. That link in the upper right, if site, you can get a copy of it. Aerial survey is a project that's been discussed as part of the ICEAL committee work for years and years. So all the work here has been thoroughly vetted through that co-management process. So from that, I will pass it on to Erin. Thank you.
Thank you, Mike. Okay, so I'm going to be sharing with you our plans for this spring, actually starting next week. We have been working towards developing current abundance estimates and distribution maps for these species over the past decade or more. The goal is to determine those abundance and distribution of ringed, bearded, spotted, and ribbon seals. And we started this current methodology back in 2012 in the Bering Sea. And it's taken us a lot of development of our technology and our approach to cover this whole area. And now this next year, we're going to attempt to survey all 3 seas simultaneously. The surveys occur in the spring when seals are out of the water and up on the ice to pup and molt. That makes them a whole lot easier to count from the sky. We are using a suite of cameras in the open belly camera bays in a couple of airplanes that I'll show you in a few minutes. And using cameras has allowed us to fly at higher altitudes than traditional surveys. When we first tried to survey the Bering Sea, we were using helicopters off of icebreakers, and we had to fly much lower altitudes in order to differentiate the different species with the naked eye. So cameras have really helped us expand the area that we can cover and the detail that we can retain from the survey. And as Mike just described, we have discussions with our co-management partners, with the ICEAL committee throughout the year. And we've also done quite a bit of work to reach out to coastal communities and whaling captains associations. So for this year's survey, we'll be there in Nome on April 1st, and we'll be wrapping the survey effort up on June 9th. And the map shows the airstrips that we have available to us. How far south we go will depend on the ice extent, of course. The way this works, so when you're looking at the map on the right there, the blue grid is our survey area, and it's also it guides our sampling approach. So each night we download the most current sea ice imagery, add it to our map project, and then plan the track line for the next day to align with the guiding principles of the analysis. So it's very different from other line transect type surveys that you may have seen pictures of, where there's set lines and they always fly or survey that same track. Ours is much more dynamic because the habitat that we're surveying is moving and changing throughout the survey window. So that's something that's a little bit different about this type of effort. The little peach circles you see on the map are areas where around communities that are engaged in whaling subsistence activities during the time that we're surveying. So through over the decade of communicating with different communities, we've established some of these buffers to ensure without a doubt that we won't be, by chance flying over anyone that's out subsistence hunting. Our flight lines are really long and pretty spread out. So these we call these survey buffers around some of these communities, and they're they're like 30 miles from the point of the community. And our survey lines can be 30 miles apart from each other. So it's generally not a big impact to ensure that we don't, fly too close to any of these subsistence communities. So we'll fly hundreds of miles offshore, and then travel 15, 30 or more miles, and then turn and fly back towards shore. And that's kind of a standard type of flight. Or we'll fly to another airstrip. Another principle of one of the main principles of the analysis that we need to be conscious of when we're developing these track lines and figuring out where we're going to fly is that we want the effort to be spread out over space and time. So if our statistician had his ways, we would never stay in the same place 2 nights in a row. We would always be on the move. We have negotiated with him to stay a few nights in each location. One of our planes will be in Nome for quite a while because it has quite a far reach. So we can have some stability in the logistics and still get a lot of sampling in. So in this whole blue area, there could be 2 flights happening kind of anywhere on any given day. And then we, of course, have, mandatory pilot rest days. And then I'm sure we'll have our share of weather days. And then, of course, if the planes need any particular maintenance, then those are days that we're not flying also. So these are the 2 planes in the lower corner. The plane on the left lower corner is the Twin Otter. It's a high wing platform with big bubble windows. It's a really great observation platform. And then we have the King Air, which is a little bit smaller, low wing. This is a pressurized plane, so it's going to allow us to fly at higher altitudes to reach some of the areas that are farthest from an airstrip. So we will have the King Air the entire time, that smaller plane. The Twin Otter will have until mid-May, and then it will transition to another Alaska project that's called Arctic Air. It used to be called Arctic Heat. That might be familiar to some of you. They often fly out of Nome and Kotzebue. So, but after the 13th, that plane will be on their mission. Both of these planes have very similar tail numbers. The King Air is N68 RF and the Twin Otter's N56 RF. So often kind of the type of plane, it makes it easier to distinguish than the actual tail number. Each of these planes will have or have at this moment a suite of cameras that are mounted in an open air belly port. The Twin Otter has the exact configuration that you see in the upper right corner there. That plane will carry 3 cooled thermal cameras, 3 high resolution color cameras, and that plane will be collecting some ultraviolet imagery as well for some experimental projects that we have going on with detection of bears and whitecoat pups. And then the King Air will fly with just the thermal and color cameras in the same configuration. So those cameras are all lined, so they're covering the same area on the sea ice below the plane as we fly along. The survey altitude is 1,000 up to 1,200 feet. If weather pushes us down below 800 feet, we are no longer surveying at that point. We're looking around for better conditions. And our survey speed is really based on the plane and, of course, the current conditions. We're trying to maximize the range of the plane, so we are flying as fast as is efficient for that aircraft in those conditions, and that tends to be around 120 to 150 knots. And then we are looking continuously while we're over the ice with the cameras. So this is an example of what the thermal and color imagery look like. So the thermal image on the left, it's grayscale, and the darker the color, the cooler the temperature. And so, of course, the seal in that picture is putting off a nice bright, what we call a hot spot. And that is what we're looking for. So we detect the animals in the thermal imagery, and then we use the color imagery to identify the species. So, so this, you can see clearly we have a nice big bearded seal in this image set. So the detection is actually done using artificial intelligence models that are trained to find those little white hotspots. And then we've also been working on models that can differentiate species and find the animals in the color imagery. And during our last survey in the Beaufort in 2021, we were able to test this approach of actually surveying in real time. So one of the benefits to having observers looking out the window and recording what they see is that when you land the plane, you have your data. When you're collecting images the whole time, you have a lot of work to do after the survey effort is over to find those animals. And so these deep learning models have proved to be a really great way to help us identify which frames or which spots are likely animals. So our system now that we're flying with can run those models in real time during the survey effort. So this is an example. This primary image you're looking at is our map with some sea ice imagery loaded. And then the track line is showing you the actual footprints of the camera, the images that the camera is collecting. And then it's also mapping every place that the model that we were testing found and identified an animal. And you can see that there is a species provided, and then there's a long digit code following it. And that number is kind of like a scale reflecting how people often use the word confidence, which is a little bit weird when you're talking about a computer, but it's really kind of reflecting how well what it found matches what it was trained to find. So it knows it's looking for all these different ways that a ring seal might look, and this one looks very much like what it's trained to look for. So that's going to have a higher score. So you'll see some of these say, like at the top there's a ring seal 0.9588. That's a high confidence score. That's likely a ring seal. I'm sure that is a ring seal. Above that, you can see two bearded seals, 1.12 and 1.99. The 0.12 is probably not a bearded seal, and the 0.99 probably is one. So, so this being able to do this in the plane means that we are able to land with much better information than we can if we just have a million images. And then when we get back to Seattle, we'll be having biologists review those images and those detections to confirm or deny the species that's assigned to that animal. So then we have all of our counts, and to determine the abundance and distribution, we need to take into account a lot of other information aside from just those numbers. So I'll just work around this image starting with the upper left. So that graphic shows some seals hauled out on the ice and some under the water. And when we're out on our vessel-based work that happens every couple of years, we attach satellite tags to the animals, and the data that we get from those tags lets us know how much of the time and when animals tend to be out of the water or tend to be in the water. So that allows us to account for the seals that were in the water at the time that we were surveying. And then, as I mentioned, we use the satellite imagery of the sea ice to help plan the survey. And then that information is also used in the analysis. So that tells us, the satellite data is telling us how the ice was changing during our survey effort. And then in the lower right, you can see from our Chukchi surveys in particular, and our Beaufort, our Bering Sea surveys. At that time, we were able to collaborate with Russian researchers and incorporate their published data to better understand how seals are using the broader habitat. So if we see, a decline in population, but we see an increase on that side of the border, then you can see how animals might be using their habitat differently. They obviously don't have any awareness of or regard for political boundaries. So that's really, in the past when we've been able to do that, it's really valuable information. So that actually gets incorporated, and we analyze all the data together when we have access to that information. And then we have a number of things that we do to check and measure the error around just the process in general. And one of those things is having somebody look through a set of just color images that's a sample of the whole image collection, and they look for animals just that they can find in the color imagery. And then we use those animals that they found, those seals, as a quiz for our process. And we see how many of those animals that a human found looking through pictures did we find using thermal imagery and a model used to, a detection model to find those animals, and having them reviewed by people back in the office. So that allows us to understand what types of how many animals we might have missed just in our full process. So we combine all those types of information, and then we end up with abundance and distribution maps for the various ice conditions that we witnessed during the survey effort. So we're going to be going through the same process with the data that we collect this over the next few months. And this example is from the Chukchi, which was a joint effort with Russia. So when you look at that shape, it is the Strait is down there at the bottom, and then it's extending into the Russian Chukchi and the Eastern Siberian Sea as well. So across the top, you have sea ice concentration. The rows are just some sample dates from throughout the survey. So early April, early May, and late May. And so you can see how during the survey window from 2016, how the sea ice concentration changed over the course of our survey. And then you can see in the distribution maps for the bearded and ringed seals that we detected, how they were using that ice changed throughout that survey period as well. So we'll be coming up with the same type of information, but not just for the isolated, not just isolating each sea. We'll be able to look at it all together, which will be really valuable information. So we've talked a little bit about having some survey buffers to ensure that we're not, reducing the likelihood of us flying over any active subsistence hunting activities. And so this is just a list of either elements of our survey that in and of themselves are, help reduce the likelihood of us really kind of encountering people or causing any disruption to coastal communities. Inherently, having cameras in the plane allows us to fly higher and faster. That actually minimizes the amount of time that we're in the air, and allows us to complete our surveys more quickly and get farther away from shore. Our flight lines extend hundreds of miles offshore, and then they're spread out 15, 30 miles before returning through another set of those little cells. Our pilots are actually instructed to turn around if they see people on the ice or in small boats ahead of the aircraft. And this is kind of an unusual request. The pilots are generally really curious about, the environment that we're in and the types of things they might be seeing. But we ensure that we don't go kind of poking around and just exploring, anyone that we might see out on the ice on snow machines or in boats. We do ask them to monitor marine radio frequencies, and we publish those daily in our update emails that I'll show you in a moment. So hopefully those are far-reaching enough so that folks understand that they'd be able to hail that plane if they actually did need some assistance, or if they are concerned about where we're flying. Let's see. Pilots are also instructed not to fly over any large groups of walruses, or later in the season, or beyond any large groups of eiders that we might see. And we distribute our flight plans every day after we've planned our survey the night before, and then we meet with the pilots and ensure that the weather is aligned with what we want to do. We distribute that flight plan by email, and in that email we provide those marine radio frequencies, and we also provide phone numbers that go directly to each flight team. And our team understands that if they get a phone call from somebody who's concerned about the plan for that day, they will make adjustments, staying within the guidelines of the survey protocol, but we're able to accommodate any needs of the communities. So this is an example of what that daily email looks like on the left. It's not text heavy or long. It just is giving you kind of the straight and narrow of what the plan for the day is, when the plane will be trying to take off, and when the planned return is, and then those radio frequencies and what the flight profile looks like. So you can see there's always a map. And then if there's any changes in altitude, those are described in the text. And then at the bottom in that gray font, which I'm sure you might not be able to, I can't read it, but you can read it in the email. It's easier to see. That's where we list the phone numbers. And then we have links to information about the project and the lab, so you can learn more about the science. But you get kind of a daily update for each plane. If no flight is planned, if there's maintenance or weather or pilot rest days, then we send out an email letting folks know that we won't be up in the air. And if you're interested in receiving this type of information, you can go ahead and put your email into the chat here, and Mike will grab it, and we'll make sure we add you to our email distribution list if you're interested. This is just an example of the amount of engagement that I'll say but it's really Mike has really worked hard over the past year in particular to get out to and visit as many villages and communities as he was able to. And then also to set up virtual meetings with groups and throughout the regions over the last year or so, into this last February, where we got to attend the Alaska Eskimo Whaling Captains Convention in Utqiagvik. And this slide shows you what our survey communication plan is in the planning stages, and then during the survey, and then our follow-up. And this has grown over the last year or two as we've received feedback from communities of what types of communication works well and what people would like to see more of. To include, we do our surveys, we collect data using GMT time, and we were kind of absentmindedly using that in our communications, which is not very helpful for people. So somebody thankfully pointed that out, and we now have made sure to change everything so that we're using local time in our communication. So it's been really valuable to do things, participate in forums like this in Strait Science, and to sit down with hunters in some of these communities and hear what's working and what's not working. And we've been working hard to make improvements. When I first started with this program back in 2006, in 2007 and 2008, we were doing these helicopter surveys, and we always had, they were vessel based, and we always had a Native Alaskan hunter participating. This is Mike Apatiki from St. Lawrence Island, from Gamble. And it was always such a really incredible part of the experience. And since we've moved to cameras and planes, we haven't been doing this as we haven't been incorporating this element as frequently, and we're working on getting back to that. So we've been talking with people about having folks participate on the Otter in particular, just because it's a bigger plane, it's a bit more comfortable. We'll have room in the King Air as well, and there's some training that's required. And we need about a week's notice, but we're working with the ISEAL committee to help us connect with folks who might be interested in participating in some of our flights. And that is all that we have for you all tonight. But we'd be happy to take any questions if I didn't miss them. I'm going to go back over and see if I'm still connected. Hopefully.
Great. You're still connected. And thank you, Erin, and thank you, Michael. We really appreciate your time tonight to make sure we're aware of what is coming pretty soon to us. And if you're thinking of your questions, this is the time for the Straight Science audience to send a little love to Erin and Michael in the chat box. They survived the storm so far, so that's good. And it's never easy to be a public speaker, and they are on a different time zone, so it's very much after their typical office hours, and they're taking the time to let us know again what their efforts are going to be. And it sounds like you guys will be arriving April 1st, so that'll be very, very soon, and we'll look forward to that. I guess my question is, how many of you are there when you arrive to Nome? So we sort of.
Oh yeah, great question. And just to let you know, I've tried to have my camera on, but it keeps turning itself off. So I'm not sure if it's just regulating me. I'm trying to give you some FaceTime, but I will be there next Monday. So we will start with 2 planes. Each plane has 2 pilots and a mechanic. So there's 6 in our flight crew. And then we will be starting with 3. We will be starting with 3 to 4 scientists. So myself, Ben Ho, and Stacy Kloslowski will be starting, and then Jessica Lindsay will be joining us about a week later. And the King Air will typically only have 1 scientist on board, while the Otter will have 2. So that's about the size of our. Oh, I think I've been. Can you still hear me? I'm getting an error
Yes,
message.
we can hear you very well. It just looks like your video is somehow thumbed up. That's okay.
It's telling me to rejoin, so I guess I'm having some sort of issue. But my apologies. So there's going to be 10 of us there over the next week or 2, and then the planes will start to spread out. The King Air will stick around in Nome for a while, and the Otter will start moving, so that we're getting that sampling, that spread out in space and time approach to the survey.
Okay, and there's no ship this year.
That's
no
right.
ship. Yeah.
Okay.
We're hoping next year for the ship.
All right. Yeah, I bet things are a little bit. Lot going on probably at your NOAA end. Let's see, we'll throw it open to the audience. Any questions for Erin or Michael? on their survey effort that will be in the region up and down the West Coast, but specifically in the Bering Strait region where it's easy to fly over land or near land in our region. Any questions? Well, then I get to go. I'll pick me. Pick me. All right. So I just wanted to say the artificial intelligence you guys are using, that's pretty incredible that you're able to just sort of put it on, you're filming all these things, or that camera is picking up all these seals. I would estimate it probably takes a lot to get that data, which must be tons and tons and tons of data on objects that it's trying to figure out. How long before we may get a answer on how the seals, because I think we were, there's some going to be some comparison looking forward and looking backwards as to what you had last time you guys did this effort.
Yes, that's right. That's the big question. As Erin mentioned, these are incredibly complex and statistically complicated analyses to make. But before those analyses can even be conducted, we need to be able to analyze the sensor data that we're collecting. That requires us being able to extract as Erin mentioned, extract the hotspots, identify which are seals, identify those seals to species, do quality control, link them up with habitat variables that are going to be part of the model, and then run the model. These take a long time. So it will be more than a year, closer to a 2 or maybe even into the 3rd year before we're going to get final estimates for all of these. We like to try and wait to publish the numbers until we've gone fully through the peer review process. Sometimes, though, we've felt comfortable giving kind of rough numbers. And when I have those available, I'll be sure to bring them up at a next Strait Science.
Wonderful. Because I can see there's a couple comments, a lot of comments on great presentation. So we thank you both. And also like Jackie Schaaf is looking forward to hearing how the survey goes. Edwin Nungok, it'll be interesting when they have their data to share. So we'll all be wishing you well. And we very much appreciate you bringing this to us again as to what your survey is for and then how you're doing it, when we should expect this region to maybe see those king airs, and then coming back and telling us what it's doing. Plus, it's great you're doing the daily updates to all the tribal offices, as well as the people who, anybody want to get on their list, they're more than welcome to. And I put your emails, I took the liberty of putting your, Michael and Erin, your emails in the chat. Some people don't feel comfortable putting their emails down. So people can, more lightning. So people can email you directly, and you'll be able to work with them to get whatever it is you need done, so they can get your information.
Excellent.
All right. Any other questions? My last one was Russian news. So I know that you guys, when things were a little bit pre-Ukraine war, you had collaboration and were always interested in this very narrow transboundary shared waterway to know what's going on for our neighbors, just like they probably wonder what we're doing. I know that last time you were hoping they were going to maybe not communicate, but you were going to kind of try to fly at the same time. I know that you've done this in the past like that. Are you in zero comms, or is there any kind of hope that they'll be pulling off something at their end of things on the Chukchi?
Yeah, it's a good question. So just a little bit of background. Our earlier surveys, the ones in 2012 and 2013 in the Bering, and our survey in 2016 in the Chukchi, we had very close coordination with our Russian counterparts. They were conducting very similar surveys with nearly identical methods. We analyzed the data in very similar ways, and we were able to, as Erin showed, publish abundance estimates that were really good for the entire region, all of the Bering and all of the Chukchi. As you mentioned, we have not been able to be in any kind of close contact with Russian counterparts for a few years now, mostly due to the Ukraine invasion. For that reason, we don't know really what they are planning. We are hopeful that they have seen your Strait Science presentation and know what we are planning, and hopeful that they're going to be able to mount similar aerial surveys on their side of the border. And ultimately, if that does happen, ultimately we hope to be able to combine our data sets as we have in the past to be able to have really good abundance estimates.
All right. Actually, you make me ask the question while you're in Nome. Mike, are you coming to Nome yourself, or I know Erin is. That's great. Are you coming to Nome?
I will be coming to Nome and Uktiavik, and I think Dead Horse is my current plan, but I won't be there until late May, if I'm not mistaken.
Just as a thing you might be thinking about, we have 2 radio stations that probably would love to interview you, and those would play the story either in one case there may be translation, and in another there would not be, but those would be broadcast straight over. They're in our radio pickup. They're listening for the weather and things like that on the Chukotkin side, National Weather Service, hourly weather and whatnot. And we do have news that goes back, we're broadcast one way. It just may be something to put in your toolkit to help interested parties on the other side understand, oh gosh, you're actually gonna get a good number and things like that.
Yeah, for those, there will be other people that will be in Nome and all the other communities before me. So I think that would also be a great thing to try and organize for those other folks from the Polar Ecosystems Program. They're going to be in Nome. They can also give very knowledgeable. They can give those same presentations if I'm not there.
Wonderful. Erin will be in touch with you. Hopefully you reach out when you get here, and maybe we can set something up there.
Yeah, that'd be great. Thank you.
Yeah, it's always good if we can to get word of something shared as far as we can to all our neighbors in the neighborhood here. With that, thank you, Edwin. Edwin's left his email address down there, so I know, Edwin, you'll probably be getting the updates. Oh, there you go. Thank you, Erin. You're already on it.
Okay.
I think we're all interested in the outcome as well, but we'll tune in the future here. And we really wish you guys well. And with that, any other questions from the audience? All right, I'm going to ask Erin and Mike if you could stay on for just 1 second. And next week, Strait Science will be on its normal Thursday, so that will be April 3rd. And we have also the NOAA Alaska Fisheries Science Center. They are going to be talking about the large whale survey that was part of the International Whaling Commission's large whale survey in the Bering and Chukchi Sea. We've got Jessica Krantz. She will be giving us 3 years worth of results. Thank you, Edwin. She'll be giving us 3 years worth of results on what happened in 2024 when they came up here to look for and document the status of large whales. And that's a whole bunch of different whale species. So we're excited to hear from Jessica Krantz in Seattle, and that will be next Thursday night. Other than that, we thank you so much for coming, and we'll see you next week. Good night, everybody.